Hello everybody, in this video we're going to talk about some properties of trapezoids. So first of all, what is a trapezoid? It is a quadrilateral with exactly one pair of parallel sides, and those parallel sides are known as the bases. So if we look at the trapezoid on the left side here, we have a trapezoid labeled with the different features of it. So we see here at the top and the bottom that these are called the bases. Not always going to be the top and the bottom, that's not really what we're looking for. We're looking for the two sides that are parallel. Those are the bases, right? So this shape could be rotated on its side, so the bases could be on the left and the right. So don't let base make you think top and bottom. You're looking for the two sides that are parallel. Okay, along with that, we have base angles. So the base angles are just located at the angles of the bases, right? So wherever the two parallel sides are, you've got two top base angles and two bottom base angles. The other part, or the other two sides of a trapezoid are called legs. So those are just the two sides that are not parallel, okay? Not always on the left and the right, keep in mind. Could be top and bottom if the figure has been rotated, okay? One specific trapezoid that has a lot of properties with it, easy to work with, we're gonna talk about it here in just a minute, is called an isosceles trapezoid. So if you remember the word isosceles, we talk about triangles, isosceles means two congruent sides. Well, if we think about a trapezoid, we have the two parallel sides here, right? Those are our bases. And notice here that the two legs are congruent. So this is called an isosceles trapezoid. Okay, and we're going to spend the majority of or the rest of this video talking about isosceles trapezoids. Okay, all right, so let's talk about a couple properties. First of all, with the base angles, if we do have an isosceles trapezoid, the two pairs of base angles are congruent. And let's look at what we mean by that. So the two angles that are on the one base, the same base, they are congruent to each other. And then the other two angles that are on the other base, they are congruent to each other as well. Another thing that we can think about is the two angles that are on the same leg. They would be supplementary. Why? Because essentially we have two parallel lines cut by a transversal. So these would be same side or consecutive interior angles that we've looked at previously in geometry. Also, one thing about the diagonals are congruent to each other. So we could say diagonal BD is congruent to diagonal AC, okay? All right, now there is also something called the trapezoid midsegment theorem, and that's what we're gonna talk about here. So the midsegment, it's located where it sounds like, right? It's in the middle of the trapezoid, and it has three properties, okay? Number one, it splits the legs into two congruent parts, right? It bisects the legs of the trapezoid. And this doesn't have to occur in an isosceles trapezoid. This can occur in an isosceles trapezoid, but it can occur in just any trapezoid that you see. So first thing we want to note is that it bisects the legs of the trapezoid. Also, the midsegment is parallel to the bases, and the length of the midsegment is half of the sum of the other two bases, okay? So we take the base number one, base number two, add them together, take half of it, and that's the length of our midsegment, okay? So we're gonna do a couple examples by finding the length of the midsegment, one in just a drawing, like we see in example one, and then one in a coordinate plane, we see in example two. So number one, we see that the base on the top is 35 inches, so we're gonna take 35, we're gonna add that to the base on the bottom, and then we're just going to divide that by 2 or multiply by 1/2, okay? So we get 1/2 times 35 plus 41 would be 76, and that gives us a length of 38. So we could say our midsegment is 38 inches, okay? So easy enough. Now, when we talk about it in a coordinate plane, it could get a little trickier because we might need to use the distance formula. So let's look at our trapezoid here. Notice that the bases are not on the top and the bottom, right? So if I see this base here, we can tell that those two are parallel to each other. We could verify that by finding the slope of those two lines, but they look parallel, right? So if we look at the other two sides, AD and CB, those are definitely not parallel. So if this is already given to us that this is a trapezoid, we know that the two bases are towards the right and towards the left. So in order for us to find the length of the midsegment, we need to find the distance of each of the bases, add them together, and then divide by 2. Okay, so let's do that for side AB. Now to find the distance, or the length, we're going to use the distance formula. So I'm going to say -1, this is the x-coordinate of A, minus the x-coordinate of B, so -1 minus 5 squared plus 3 minus -3, so I'm going to say 3 plus 3 squared. And now we can simplify this a little bit. So -1 minus 5 would be -6, and 3 plus 3 would also be 6. And so now we get -6 squared would be 36, 6 squared would be 36, so we add those together and we get 72. So now let's simplify that radical. So 72 would be 9 times 8, but then we can go a little bit further than that. It's 36 times 2, right? So 36 times 2, square root of 36 is 6, right? So this is square root of 36 times the square root of 2. Square root of 36 is our perfect square, so we get 6 root 2 for our length there. So I'm just going to circle that for now. Remember, we need to add that to our other base here in just a second. Okay, so I'll draw a line here, separate our work, and now let's find the length of DC. Okay, so we're gonna do the same thing, distance formula, and let's take the x-coordinate of D, so -3, minus the x-coordinate of C. C's x-coordinate is -1, so I'm gonna say +1, right? Minus a negative becomes plus a positive. And then y-coordinate of D, -1, minus -3, so -1 plus 3, and we're gonna square that. Now we can simplify our radical. -3 plus 1 would be -2 squared. -1 plus 3 would be 2 squared. Okay, so now we get -2 squared is 4. 2 squared is 4, so we get square root of 8. And we know that would be 2 times 4. So square root of 4 times the square root of 2, if we're going to reduce that, and the square root of 4 is 2. So now we have 2 root 2. Okay, so now in order for us to find the length of midsegment XY, we are going to add, so we're going to take 1/2, we're going to add 6 root 2 plus 2 root 2. Well, when we're adding radicals like this, if we have the same, if we're adding with the same radical, so root 2, we can just add the number that's on the outside. So we can say 1/2 times, and then we do 6 plus 2, and we get 8 root 2. And so now this is the same as doing this, 8 root 2 divided by 2. So we can do 8 divided by 2 there, and we get 4 root 2. Okay, so the length of our midsegment would be 4 root 2 units. Okay, and those are properties of trapezoids.